Hey everybody, welcome to this first lesson for your business statistics or business analytics course. So today we're going to be looking at two chapters. The first chapter is a short one, just an introductory chapter to really what statistics are and certain keywords that we're going to be using a lot throughout the course of the semester. And then the second half of this lesson will be spent exploring the first topic, which is descriptive statistics, but from a visual side. So we're going to be looking at the different graphs and lines and charts that you should know for this course. So let's start with the most basic thing to understand, and that is data. What is data, right? This is a stats course or an analytics course. So we're going to be analyzing a lot of data. Now, data refers to any information in its kind of raw form, right? Like your name is data. Your age is data. Your salary is data. And the term data set refers to all of the data that I collect as part of a study, right? So if I were to create a survey for students, and in the survey it asks you how old you are, what is your major, and what school you go to. All of your responses would be my data set. And each one of you students would be considered an element. An element is basically the individual people, objects, or places or other entities that we are studying in the study. And then every question that I asked, your school, your age, your major, those are variables. And we study those variables, and we compare variables, and we find relationships between variables. That's what we're going to be doing over the course of this entire class. So what we're doing in this chapter is just learning how to classify data, what are the different types of data, and then we'll be on to the next thing. So first we'll talk about the difference between something called cross-sectional data and time series data. Now, cross-sectional data is when you're looking at multiple either subjects or different data points or different elements, or perhaps even different variables at the same point in time. And that's the key. You're looking at different things, but at the same point in time to compare. So if you're looking at this table shows you the number of wins by these three hockey teams over the last 6 years. Now, if I looked at all three teams, but in the year 2024, that would be cross-sectional data because I'm looking at different subjects, but at the same point in time so that I can compare how they did. Versus time series. Now, time series data is when you're looking at the same thing, the same subject, the same data point, whatever, but over multiple consecutive time periods. So if I looked at just one team, let's say the Colorado Avalanche, and how many wins they had in each of the last 6 years, that would be considered time series data. Okay? So that's the difference. Now, moving on to another set of classifications. Now, data can either be qualitative or quantitative. Qualitative data is anything that is not a number, that is a word or a group of words or a category, right? So something categorical like the color of your hair, the school you go to, how satisfied you are with your the service at the dentist's office. And even something that can seem numerical, but that is grouped into categories. For example, if I asked you what age group you're in, right? You've all seen those surveys, right? Where it's like, what age group are you in? 20 to 30, 30 to 40, 40 to 50, 50 to 60. Well, that is still categorical data because the answer, the response is a category. It's not a number. So any data that is not a number is considered qualitative. Versus quantitative. Quantitative is anything numerical. Like your age is a number, right? If I said, what is your age? And you said 21 or 22. That's a number. That's quantitative data. Your annual salary, your GPA, the temperature outside, right? This is all quantitative data, numerical. Now, if we take it a step further, qualitative data can either be nominal or it could be ordinal. The main difference is whether or not there's a meaningful order. Think about anything that is categorical, like the color of your hair. There's no meaningful order there. If I was writing a survey and I had all the different options, sure, I can place them in alphabetical order if I wanted to, but that doesn't really mean anything in the context of the color of your hair, right? There's no meaningful order. So that's nominal. But if there is a meaningful order, like if I were to ask you, what is the highest level of education that you've attained? And I gave you options. High school, some college, bachelor's degree, master's degree, PhD. You see, in that case, there is a meaningful order because one comes before the other. So that would be an example of ordinal data. Okay, so that's the difference. And both of them are qualitative. Now, as far as quantitative ones, we can also split quantitative data into two subcategories, interval and ratio. So for interval, there's only one you need to know, and it's temperature. It's really the only one. And essentially the difference here is that, first of all, the zero. In interval data, the zero is not absolute, meaning that zero doesn't mean the complete absence of that thing that we're looking at. 0 degrees is just the temperature. Doesn't mean there's no temperature. That is the temperature. And then it's not proportional. When it's 40 degrees outside, it's not twice as hot, or there isn't twice as much temperature as when it's 20 degrees, right? It's not like that. There's just different temperatures. So that's interval. And then ratio would be anything that is numerical, but does have an absolute zero. Basically, every other numerical variable falls into this. So think about, if I asked you, how much money do you have in your bank account? Well, 0 is absolute. It means there's a complete lack of money in your bank account, the complete absence of money. And if I said, you have $20,000 and I have $10,000, it is proportional. You do have twice as much money as I do. You see the difference between asking you the temperature and how much money you have in your bank account in terms of this, what the zero means and whether or not it's proportional? That is ratio data, okay? So you have some more examples in this table that you can follow. Okay, I hope that was clear. Now you've got some other definitions here that you can kind of read over. A couple of them that I want to talk to you about: primary and secondary data. So primary data is any data that you yourself have collected. So you did a study, or you have sat and observed people. So anything from your own experiments or own observations would be considered primary. And then secondary data is data that someone else collected and you're just kind of repurposing, right? So you went into a database, you found a research paper, you liked it, you looked at the data, now you're using that data. That would be secondary data. Okay. Now, as far as population samples and traditional statistics, we'll quickly run through this. Nothing crazy here, probably things you've already heard. So when we say population in the context of really anything, a population is the entire population of the elements that we're interested in. So every single element that you are interested in knowing something about. For example, if I wanted to know what the average profit is for a company in its first year of business, or startup, let's say. What is the average profit that a startup makes in its first year of business? Well, the population would be every single startup that ever existed. That's a lot of startups, right? So the population is typically very large, and you often don't have access to it. So we take a sample. A sample is a subset of that population. So we say, okay, well, look, I'm going to go out and find 100 startups and ask them how much profit they made. So the sample is simply a subset of the population that you're interested in. And we use a sample because it's typically, one, much easier to gain access to, and two, typically will be enough to give us really, really good information as long as we can get a sample that's large enough. Obviously, a sample of 2 is not good, but if you can get, and we'll learn this over the course of the semester, 20, 30, 40, 50, then the sample becomes pretty reliable, where the population wouldn't have really given you much more. Now, traditional statistics, something we're going to be basically doing over the course of the entire, this is really what the course will be about, these two things. Descriptive statistics is typically what we start with. right? So what we're going to start with, this is really learning how to describe what you see in a statistical way. So calculating an average, for example, is a descriptive statistic. Drawing a bell curve or a histogram. Computing a standard deviation. Things like that. These are descriptive statistics. We're just describing the data. Then we take that information and we move to the second half of this course, which is inferential statistics. Now, what inferential statistics means is when we take a sample, what we're doing is we're taking the sample so that we can gain information and make an assumption or make some conclusion about the population, right? So if I were to go and take my 100 startup sample and the average profit that they made was $5,000, well, I could say, well, we assume that the population, that all startups would have an average profit of probably around 5,000. Now, it's not perfect, but we can say that with a pretty high degree of confidence because we're able to gather that information. So you see what I'm doing there is I'm making an assumption about the population using information gained from the sample. That's inferential statistics. So things like hypothesis testing, things like interval estimation, linear regressions, all the things we typically do in the second half of the course, right, it falls into that category. Okay, so that's really all the time I want to spend on the introduction. The rest of the course will be spent on this section, which is the first part of descriptive statistics. So split up into two parts. The first part here will be just looking at the different graphs and lines and certain tables that we're going to make. And then the following chapter, which will be the next lesson, we're going to get into the numerical side of descriptive. Hey everybody, sorry to interrupt. I just wanted to quickly ask you guys to follow me on Instagram. You can use the QR code here. You can type in my username. It's really the best way to reach me for questions if you do have any. If you wanted to have access to me more regularly, chat about certain things, talk to me privately, Instagram is really the best place to reach me. So in this chapter, we're going to be diving deep into the different lines and graphs and charts and tables that you want to know in statistics. And we're going to do this in kind of two parts. The first part, we'll talk about the different graphs and lines and charts that have to do with qualitative data that you would use to, show qualitative data, and then we'll do quantitative data after. So remember that qualitative data is anything that is categorical. So the first thing you want to know is something called a frequency distribution or a frequency distribution table. And remember, the word frequency just means like how many, right? So a frequency distribution table is a table that summarizes the frequency of every one of your categories. So, here I have a survey of several students and asked them what major they're in. And then I counted how many said they were in accounting, how many in finance, how many in marketing, and so on. And so the frequency is simply that, right? How many times did each category come up? And then you have something called a relative frequency. A relative frequency is a proportion. A relative frequency is basically your frequency divided by your sample size. The symbol for sample size is n, lowercase n. We'll be using that throughout the entire semester, so get used to it. F, in this case, would be frequency. So you see, if 54, and we're going to make one of these after, by the way, but just for now, if whatever the total here happens to be, let's add that total. So 54 plus 46 plus 64 plus 75 plus 125 is 364. There's 364 students that responded. So 54 out of the 364 are in accounting. That is the relative frequency. It's frequency divided by sample size. Okay. You can also express it as a percentage, right? It would be about 14.84%. Now, as far as the charts that are most commonly used for qualitative data, we have the bar chart. So a bar chart is simply a chart. It could be vertical or horizontal, where the height, if we're talking vertical, represents the frequency. So the taller the bar, the higher the frequency. The order here doesn't really matter, right? As far as like what I put first, here I have what are the 6 reasons for returns on Amazon. And you can see they're either damaged or defective or incorrect or redundant and so on. And you see defective is the highest. Right, that has the highest frequency. The second would be that they were unsatisfactory, then incorrect, then damaged. So really all you need to know here is bar charts are used for qualitative data. The width of the bar should always be the same. Okay. The only thing you should be playing with is the height. And there should be a gap between them, and that's the difference between a bar chart and a histogram, which we'll see later. So the width should be the same. The height represents the frequency, and we use it for qualitative data. Another really common one that I'm sure you've seen is the pie chart. It's the same data here. These are the reasons for the returns on Amazon, but the pie chart is basically showing it to you in a different way, where of course you take a circle, and then the larger the slice, the higher the more important that category is. So here we don't really see frequencies. Instead, we see more of a relative frequency, right? Like this represents about 28% of the data, or 28% of the sample data, and it makes up 28% of your pie. So as far as the number of degrees here, remember that a circle is 360 degrees. So if you were to take 360 and multiply it by 0.2829, 360 times 0.2829, it's about 101.84 degrees. If ever you're asked a question like, how many degrees should the slice have? Well, that's how you would do it. You would take the relative frequency, or the percentage, and multiply by 360, and that's going to tell you exactly how much of the circle that particular category would hold. And then you've got something called a Pareto chart. A Pareto chart is like a bar chart, but it's been rearranged going from the highest frequency to the lowest frequency. We use this when we want to identify the more important or least important categories, and it's very often used in situations of like defects and mistakes, where we try to identify what is the leading cause of errors so that we can address those situations. So it's really a bar chart placed from highest to lowest. And then you've got this line here. The line is called an ogive. And the line represents the cumulative percentage, right? So if you look at the right side, you have a second axis. And that first point right there, if I were to draw a line, it hits it just under 30%, which means that first category is 30%, just about 30% of the entire data. 30% of the returns on Amazon are because of the units were defective. And then if you go to the next point right there, and you draw a line all the way to the right, that's just over 50%. Let's call that 52%. Well, that means those two categories together, the top two categories, make up 52%. You see, that's the point of the ogive. We want to see for every category, not the percentage of that particular category, but all the categories up to it, right? So if I go to the next one up here, and I draw a line, that's at about, we'll call it 75%. Again, the first three categories together make up 75% of the data. So if for Amazon, 75% of all their returns are either because the units were defective, unsatisfactory, or incorrect. And it goes up, up, up until eventually it reaches 100% on the last category. Great. Now, quantitative data is where we're actually going to start working. First of all, with quantitative data, you can also make a frequency table. The difference is because data, because there's so many different numbers, right? They're not categories where you have 5, 6, 7 different categories. You have numbers. It could be like an infinite number of values. So the frequency table, when it comes to quantitative data, first of all, has to be organized in categories. Right? So you end up with categories like this, right? If I was asking your salary and you told me it was, $53,492, well, I would place you into one of these categories. So one of the things we'll learn is, well, how do we make these categories? It's not arbitrary. It's not just, I feel like making it 30 to 40, 40 to 50. There are specific rules you have to follow in determining how many categories you should have and how wide each category should be. We'll get into that, okay? We're just going to run through like what things are, and then we'll worry about actually doing it. The frequency and the relative frequency is exactly what we spoke about before. The cumulative frequency is the accumulated frequency. So you see, it's accumulating. Let's say the first category is 17 because that was 17. But then the next one is 39 because it's 17 plus 22. That's the 39. And then if I add in the next one, the next 25, I get to 64. And if I add the next 32, I get to 96. And we're just accumulating it. And then same thing for the cumulative relative frequency. You're accumulating your relative frequency. This is similar to the ogive that we saw before, until we reach 100%. Graphs that you can make, the histogram. So the histogram is basically a bar chart where the bars are stuck together. And we do this because this data is continuous, where as soon as one category ends, the next one begins. And so you see they're stuck together. Again, the rules really, you don't want to have any overlapping categories, which is why you see us do this, right? The 40,000 is excluded here, and we included here. We don't want to have any overlapping categories where you can place a number potentially in two different places. You want the width of each one to be the same. And you typically don't want to start or finish with an empty category. So a histogram shows you the frequency of each category like the bar chart in that sense. You've got dot plots. These are not very popular, but they are useful in determining, in really showing you outliers. So dot plot is basically kind of like I don't want to say it's kind of like a bar chart or a histogram, but they're similar in the sense that they show you frequencies, but every single dot represents a data point. So you have this like horizontal axis, and every single one of these dots is a point. So this could be like, 31. And there's only one respondent that said 31. Maybe this is 61, and there was two respondents that were 61. And this is 68, and there was two respondents that were 68. So every dot represents a thing, a person, an object, whatever it is that you're studying. And really what we use it for is like when you see something like a bunch of dots clustered together and then one way out to the left or to the right, that's probably going to be an outlier. Later on, we'll learn in the next chapter, how do you actually measure whether or not something is an outlier. This is more how you identify them visually. The stem and leaf diagram, which we're actually going to construct one in a second, we'll skip it for now, and we'll talk about it when we're actually building it. And then scatter plots. So a scatter plot is a graph that shows you the relationship between two variables, two quantitative variables. Like, here I put the hours you spend on TikTok, which would be the X variable because it's independent, and your GPA, which in this case, we're trying to see if there's a relationship. Does your GPA depend on how long you spend on TikTok? And we see here all those little red spots, those are individual data points. That's the data that I collected from the students. And the line going through it is called the regression line, and it kind of shows you the average relationship. And you see it's negative here, meaning as X increases, as the hours you spend on TikTok go up, your GPA has a tendency of going down, right? So there's a negative correlation there between the two. So that's what a scatter plot is. We're gonna do a lot of scatter plot stuff towards the end when we're doing linear regressions. So this is where I want to spend a bit of time here. I want to solve this exercise. We're going to go through, the things I think you need to know. So here you're given this case. A manager at a tech startup frequently travels. So managers at a tech startup frequently travel for business and client meetings, and they use a company-provided credit card for all travel-related expenses. Below is a table showing the sample of 30 transactions from these trips conducted by the managers. Each transaction is in dollars. Great. So this is our sample. We have a sample size of 30 and it's all in dollars. So the first question is to construct a frequency distribution table. Now, to construct a frequency distribution table, the first rule you want to know is this. 2 to the power k has to be greater than n, where k is the number of categories. This is how you determine how many categories you should have. So, for example here, if I said, well, what if I want to have 4 categories? You would check 2 to the power of 4. 2 to the power of 4 is 16. And 16 is less than 30, our sample size, which tells me what? This is not enough categories. You should have more categories than that, because 2 to the power of 4 was not greater than your n. So then 2 to the power of 5. 2 to the power of 5 is 32. 32 is greater than 30. So this is perfect. This is how many categories you should have. Now, if you're wondering, well, what about 2 to the power of 6? That's also more than 30. You're right. But the sweet spot is that first one, the one that just puts you over, right? So 2 to the power 6 is 64. Yes, that's greater than 30, but it's not the best. This is too many categories. You should have 5 categories to describe this data. So I know that when I'll be constructing my table here, I'm going to have 5 categories. Now the next question is, well, what are my categories? Is it 0 to 50, 50 to 100, or what do I do? Well, what you want to do here is identify, first of all, you want to find your max and your min. What is your highest and lowest point? So these numbers are not in order, so this will be a little bit challenging. So I see 290 there. I see 296, so that's higher. Do I see anything in the 300s? No, great. And then the lower end, I see 103. I don't see anything less than 103. Okay, so 296 and 103 are my max and my min. So you'll take that, the 296 minus the 103, and you'll divide it by the 5 that we established here. $38.6. So what this is your minimum width. It's not the width you're going to use. It basically tells you what you can't go below. So you can use a width of 39. You can use a width of 40, 41, 42, whatever. You just cannot go below 38.6. So it's really up to you here. Now, what I suggest is just go up to the next integer. Whatever number you get here, take the next integer. Keep it simple. So we're going to use 39, okay? You could use 40 if you like round numbers, but don't go further than that. So I'm going to start with my lowest value, which is 103. And I'm just going to add 39 to it. So that gives me 142. So my first category is 103 included to 142, but I'm not including the 142. My next category will start at 142. And again, I'm just going to be adding 39 to each one. So the next one will be 181 to 220. I'm just adding 39. So now I'll take 220, add another 39 to that. And I'll do that until I have 5 categories. And you see, you should be able to fit your highest and your lowest value in these 5 categories. That's how you know you've done it right. So now we're going to have our 5. We have frequency, relative frequency, cumulative frequency, and cumulative relative frequency. And here we just start to count. So if you can count, you can do this next step. So let's start with everything between 103 and 142. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I count 10. Hopefully that's right. If it's not, we'll figure it out at some point. So 10 right there. Then I'll change the color. So 142 to 181. 142 to 1. So 1 there. 2. So the 181, we're not going to count it, right? That's part of the next category. So it's still 2. Okay, I only have 2. Great. Let's go with the next one. 181 to 220. Oh, no. Let me backtrack. I just saw the 171 there. So we've got 3. And if you're keeping track, you'll eventually find them if you miss them. So 181 to 220. I see 180. Oh, there's another one. 164. It's like I completely missed that left side. So 164. So I've got 4 in that category. Okay, 181. So 1, 2, 3, 4, 5. So 5. Okay. 220 to 259. 1, 2, 3, 4. So 4. And I'll use orange. So the rest should all fall into this one. So 260, yes. 290, yes. 260, yes. 278, 263, 263. Perfect. So 1, 2, 3, 4, 5, 6, 7. And then you count, and this is where you're going to know if you missed one, right? So if I add all these up, 10 plus 4 plus 5, 10 plus 4 plus 5 plus 4 plus 7 is exactly 30. Great. I know I counted them all. I didn't miss them, so we're good to go. You really want to take your time with that step. The rest is all just calculations, right? So relative frequency. Remember that this is the frequency divided by your sample size. So each of these will be divided by 30. So 10 divided by 30 is 0.33 repeating. 4 divided by 30 is 0.13 repeating. 5 divided by 30 is 0.16 repeating. 4 divided by 30, we had it already. And then 7 divided by 30 is 0.23. That's your relative frequency. Cumulative frequency, we're going to accumulate. So we start with 10 because that first frequency was 10. And then we add the next one. So 14. And then we add the next one. 15. 19. 19. Then we add the next one, 23, and we add the last one, 30. So easy stuff, right? Just go through it, take your time, make sure you got the frequency right. Everything else will kind of fall into place. And then cumulative relative frequency. There's two ways you can do this, okay? You can just accumulate your relative frequencies if you like, or you can take your cumulative frequency and divide it by n. So you can do your cumulative frequency divided by n, and that would give you the same thing. So for example, 10 over 30 is 0.33 repeating, but then 14 over 30 is 0.46 repeating, which is the same thing you would get if you added those two. And then 19 over 30 is 0.63. 23 over 30 is 0.76. And then 30 over 30, the last one should always be 1. So that is your frequency distribution table for this question. Perfect. The next thing I want to do is draw a histogram. And so I'm going to just grab this first part of my table, bring it here. So let's begin. I'll draw our axes. So the x-axis here is whatever the subject was. The subject for us was credit card transaction. So I'll put credit card charge in dollars, and y is our frequency. And so we have really 5 categories. We have the first one, and I want to keep an equal width. So I'll do my best. 3, so that's 2, 3, 4, and 5. And as far as the frequencies, they need to go all the way up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All set. So the first category, 103 to 142. So 103 to 142 had the highest frequency. That was the one that had 10, so that'll go all the way up to 10. And you see the next one is going to go to 4, but we'll start where this one ended. So they're connected like that. This is 142 to 181. And that's the procedure. It's really not complicated. The next one goes up a little bit higher to 5. So we'll just go up a little bit to 5. So this is 181 to 220. Of course, if you're on paper, you can use a ruler for this if you want to make it neat. If you're on an iPad, it's easier. 220 to 259 would be 4 again. and then 7 for the last category. So 7 would be there. So I'll erase that line in a sec. Okay. So let's write them in. 220 to 259, 259 to 298. There it is. And if, again, you can add other elements. This is perfect, right? You don't have to add more, but you can add data points on top. You could say, like, this is 10, this is 4, this is 5, 4, and 7. It's not necessary. Really go with whatever your prof or teacher wants you to show. Lastly, the stem and leaf diagram. So this one's a little bit different, right? We're going to go and get our data again. We'll bring it here. The stem and leaf diagram is another way to show the frequency of your different categories, but this time based on the actual numbers in the data. And so a stem and leaf consists of a vertical line, and on the left-hand side is the stem. The right-hand side is the leaf. And really when you're setting this up, what you want to think about is how are you going to cut your data? Where are you going to slice it? Let's say you take the number 249, okay? So you want to slice it typically in a way where you don't have too many categories on the stem side. You want to stay between 5 and 10 categories. Now, what determines your categories? Well, that is the unit that you choose. So for example, when you have 3 digits, you should typically be splitting it this way, where the right-hand side is the leaf, and the leaf unit is 1. What that means is any number that you place on the right side, on the leaf side, is 1 times, or 1 time that value, or it's holding the unit position, like 9 is 9. You'll see what I mean in a second. And then the stem unit is the position to the left of that. So in this case, the stem unit would be 10. So again, that means any number you put on this side is in the 10th position. So let me show you the first number, and I promise you'll understand what I mean when you see it. Okay, look. You have to locate your smallest number. The smallest number for us was 103. Okay, so take 103 and slice it where I said. You would put 10 on this side and 3 on this side. So what does that mean? Well, because I put 10 here and my stem unit is 10, somebody reading this and that does not have access to my data, imagine you're just looking at this. You're like, well, what number is that? Well, here's what it is. I see 10 here and I see 10 here. So 10 times 10 is 100. Okay, so I know that this is 100. Then I see 3, and I see a leaf unit of 1. Okay, so that's 3 times 1. So that's 3. 10 times 10 is 100. So 100 and 3. That's how you read the stem and leaf. This just tells you what to multiply the stem by. This tells you what to multiply the leaf by, and then you put them together. Now, as far as entering the data, here you want to go one by one and put them in order. So the next one number is 104. So you just put a 4 next to it. You want to try and keep an equal distance, right? So that's out. I'm going to cross them off. Oh, actually, you see, I made a mistake. 103. You want to make sure that you don't have the same one twice. So let me get rid of that, and I'll put a 3 there instead. Okay, so that's this one, and let's go through all the data. Any other 103s? Oh, there's another one there. So you see, I want to keep about an equal distance. Then I had 104. That's out. And then I had another 104. And we're going slowly to make sure we get them all. And so I'm looking for all my numbers that are, 104, 105, that in that range of 10, up to 109. So I think we're done here. And then you go to the next category. The next category would be 11. So once you start your first category, you can't skip. So because you started with 10, you got to go to 11 to 12 to 13 to 14, even if some of those categories are empty. So let's see if this one's empty. Well, I'm looking for the number 110. Oh, I found 105, so let me go put that in. Okay, so I see 111, so we'll start with that. 111 is the smallest number within that category. So that's out. Let's go through it. Do we have 111, 112, 113, 114? I see 119, so I'll put a 9. And then we move on to the next category. Everything that, all the 120s. So do I have 120? I feel like I'm in an auction. Do I have 120, 120, 120, 124, 120, 100? No, so I just have 124. So 4. 130. 130, 130, 130. So this, I used it. See, I don't have 130, but I can't skip it. So I'm going to leave it there, but I'm just going to leave it blank. Then we go to 140s. I see 141. Let me see if I have 140 anywhere. I don't. So 141. 142, 140 anything. I see 147. So that's in. Okay, good. Good. And basically, we're going to keep going until we've entered our largest number. And you see here, I'm going to be basically pushing the limit of the categories, because if you look at your largest number, the largest number for us was 296, which means I need to go all the way to 29. So if I had 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I may have to slide it up a little bit, 25. And I'm going to end up having exactly 20 categories. Now that's fine, but you typically don't want to go more than that. I'll explain after what to do if you end up having too many categories. 26, 27, 28, 29. It's going to spill into the next page, but that's okay. And I'm stopping at 29 because I need to stop at my last number. So let's keep filling this in. Okay. Anything in the 150s? I don't see 150. Okay. Anything in the 160s? No. Yeah, 164 actually. That's there. I see 171. I think that's it. I see 181. 182. 186 2 times. I see 165. I'll go and put that back in there. And then the rest are all 200s, I believe. So I can skip over the 190. So 216. So that would be here. 216. Okay. 231. 239. Then I see 260, 60, 70, 70, 249. And I see 261 two times. So when you have 260 or whatever, exactly like that, you put a 0 the way you would any other number. And I noticed the 251 there, so I'm going to go back and put that in. 263. 263 again. 278. Nothing in the 280s, I believe. And then I have 290 and 296. And just to be sure, because I know I had 30 values, I'm just going to count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Great, I've got them all. Now, if you had done this and you ended up having too many categories, like if you had the number 463 in your data, you could not use a stem unit of 10 and a leaf unit of 1 because you would have way too many categories. So what you would do in that case is you would just slide the line over and you would split your data there. So what it would look like, if you wanted to do it that way, you would have a leaf unit of 10 and a stem unit of 100. Again, you would determine that based on these two numbers. This is in the 10th position. It's a 40. It's not a 4, right? It's a 40. And this is 200. And so you would start again with your lowest number, but this time you would put a 1 here, right? Because if you're looking at 103 and you split it this way, you have a 1, and then you'd have a 0 here. Now, you have to mix in a little bit of rounding now, because you can only have one digit on the leaf side. So I would round this 103 to 100. The next, so then you would have that 3 times. Actually, you would have that 1, 2, 3, 4, 5 times, right? Because all of those numbers, 103 and 104, would all round to 0. But 105 would round to 110 if you round to the nearest. So your diagram would look a little bit different because of the rounding, right? Because this would now end up becoming 110, so you'd put a 1 there. And then you see, you would end up having to put all of these into that first category, which is why it's not really well suited for this data set, right? Because the next one would be 111. 111, if I round that, is 110. So then I have another 1. And 119, if I round that, that's 120. So I'd put a 2 here. So you'd end up with a ton of numbers there. And then when you finished all of these, you would go down to 2. And now you're in the 200s. So your first number is 216. 216, if you round that, that's 220. So you'd put a 2 there to show that number. So you see, you would end up only with 2 categories, which is too few. So remember, the sweet spot is anything between 5 and 20. Now, it's unlikely that you're going to be in a situation where there isn't like where you fall somewhere in between, where you have more than 20 if you, let's say, take this route, but then you'll have less than 5 if you take this route. Typically, exams are written in a way that can be solved if you follow all the rules, okay? And the most important thing for me is that you know how to read this, right? So if I were to just pull a number at random like that, you know, okay, this is a 2 because the leaf unit is 1, and this is a 180 because the stem unit is 10, and so this together, if I take 180 plus 2, that number is 182. Okay? Perfect. So that's it for this lesson. In the next lesson, we're going to be discussing the numerical side of descriptive statistics, how to find averages, how to find medians, standard deviations, what do those things mean? After that, we'll learn probabilities. We'll really get into the course. So thank you. If you enjoy this, please head over to my website, www.profjohnk.com. If you'd like to have access to these PDFs, if you want to purchase all the videos and follow along over the course of your semester, you can do all of that over there on my website. Thank you, and I'll see you next time.